An exact algorithm. By approximating the continuously indexed tables T of UV in discretized form, the algorithm developed in section 7.3.1 sidestepped out not only the exact computation but also a fundamental question about T of UV, namely, do the regions, the set of UV in the square of 0, 1, the closed interval between 0 and 1, such that T of UV equals to 1, have any interesting geometric structure? It turns out the answer in the case of trees is affirmative and can be used in developing an alternate instantiation of the general tree-Nash algorithm of section 7.3, one that yields an algorithm for computing all exact equilibria, but in time that is exponential in the number of players and rather than only the degree d. Although the details are beyond our scope, it is possible to show via an inductive argument where again the leaves of G serve as the base cases that in any tree graphical game for any of the tables T of UV defined by tree-Nash, the region of the set of pair UV in the square of the closed interval between 0 and 1 such that T of UV equals to 1 can be represented by a finite union of axis-aligned rectangular regions in the square of the closed interval between 0 and 1, i.e. regions that are defined as products of closed intervals between the closed interval a prime multiplied by the closed interval between b and b prime for some 0 less than equals to a less than equals to a prime less than equals to 1 and 0 less than equals to b less than equals to b prime less than equals to 1. Induction shows that the number of such regions multiplies at each level as we progress downstream toward the root, yielding a worst-case bound on the number of rectangular regions that is exponential in n. This simple, if exponential in n, geometric representation of the table T of UV permits the development of an alternative algorithm, exact tree-Nash, which is simply the abstract algorithm tree-Nash with the tables represented by unions of rectangles and with associated implementations of the necessary upstream and downstream computation. Theorem 7.6. There is an algorithm exact tree-Nash that computes an exact Nash equilibrium for any tree graphical game GM. Furthermore, the tables computed by the algorithm represent all Nash equilibria of GM. The algorithm runs in time exponential in the number of vertices of G.